So to understand RDD in depth, there is a word count example that we can use to understand how RDD actually works internally. So let's create a text. This text looks like this, which says that Apache Spark is a fast and general purpose cluster computing system. This particular text is taken from a Spark documentation. Now we want to know how many times Apache occurred, how many times Spark occurred, similarly how many times different word occurred. So first, to create the RDD, we are going to use sc.parallelize, and we will pass this particular text as a list in parallelize function. So if I do sc.parallelize, and now if I do sc.collect, you can see that we have the text available in the RDD format. So what would be the first thing that you are going to do? You are going to first tokenize this, which means that I want to separate these this particular string into different words. So I can use a split function over here. So Apache and Spark, if there is a space in between, it will get splitted on the basis of that. We have a rdd.map function. Inside the map, I am going to pass on whatever logic we want to implement on that RDD. So we are going to use the lambda variant of the map function first. So whenever we are going to apply rdd.map, then it is going to read all the elements available in the RDD. It is going to iterate it one by one and then apply the transformation that we have defined, and it will return it as another RDD. So in this particular example, since we have only one row in the RDD, it is going to read this particular row first. So the lambda x, which means that it is going to read the first row, and it is going to apply the split function over here. So once I apply this and I do the rdd.count, you will see that the count is still 1, because it has returned from a string data type to a list of string data type. Whenever we apply a split on a particular row, then it is going to split the complete text into a list. And if I want to see how it looks like, I can use the collect function, and in the output of collect function, you can see that Apache, Spark, all of them are splitted on the basis of space, and it is now a list of different words that is available in the RDD. So the first step of the word count problem is done. In this particular step, we have created the list of words from the string of words. The only issue with this particular output is that we are not able to apply the count function over here. Reason being, all the elements are in a single row. Whenever you want to apply a count, then we want the elements in multiple rows. So Apache should be one row, then Spark should be another row. Similarly, A should be one row, and A should be another row. And similarly, all the elements of the RDD should be in these separate rows. So to achieve that, there is a different function called as a flat map function. So whenever you pass an input to a flat map function, it is going to use that input, and it is going to create multiple rows out of it. So to get more clarity, let me execute this. I have done rdd.map. First, we are going to split the text into a list, and then I am going to apply the flat map. So whenever a flat map is applied on a list kind of a function, it will create more rows. So each element in a list will be created as a separate row. So if I apply this and do a collect, you can now see that in the previous example, there was a list of a list like this. So this was only one list that was available. And after applying the flat map, you can now see that each word is a different row in the RDD. So once we have the flattened RDD, we now have separate rows. Each row represents each word in the RDD. Once we have done the flattening of it, we are going to do the count. To get the more understanding on what's happening whenever we are going to perform a word count problem is, we are first going to split this particular text. So currently you can see that when we create an RDD on this text, each row will represent a different text. So currently we are only using one row. That's why we can see that in the RDD, in the sc.parallelize, when we created an RDD, there is only one row available, because we have only used one row to create an RDD. So first step would be to split this particular text into different words. So once we perform a split using the map function, then it will return a list of elements in the RDD. So first the particular data was in the form of a text. Now it is in the form of a list. So it will look something like this, and so on. Now, whenever we are going to perform the word count type of example, we have to make sure that each word is a different row. So whenever we perform a map function, you have to remember that whenever we perform a map function, then if we send one row as an input, so one in, which means that there will be one row as an output. So it will split the elements, but it will give the output as a list instead of a different rows. And then if you want to have the output in a different row, we can use flat map. The output of flat map will be a different row. So now it will be Apache will be a different row. Similarly, Spark will be a different row. And similarly, all the elements of this particular list will be converted into a different row in the RDD. So if there are multiple occurrences of Apache, you can see that it will look something like this. Similarly, for multiple occurrences of Spark, it will be on a different rows. Once we have done the flat map, to apply the count operation, how can you use count on the RDD? First thing you are going to do is you have to assign one value to each of the element in the RDD. So each of the elements that we have in the RDD, so Apache is going to get assigned 1. Similarly, Spark is assigned 1. If there are multiple occurrences, each occurrence will be assigned 1. Similarly, if there is a is, it will be assigned 1. And then if the other elements, likewise, we are going to assign the 1 to each of these elements. Once we have assigned 1 to each of the elements, the next step would be we are going to group the RDD on the basis of these words. So all the elements of similar type will come together. So Apache, you can see that Apache is one word, so it will be creating a group, and all the values like 1 will be assigned to this particular group. So all the occurrence of RDD, like over here and over here, there are 2 occurrence, so we will have 1 and 1 in one place. Similarly, for Spark, whenever we are going to apply the group, then it will be having all the occurrence of a Spark in one place. So we have the key as Spark and the value as the number 1. Similarly, if there is one occurrence of is, then we will be having 1 like this. So this is the next step. Once we have grouped the data, we just want to do the sum of the occurrence. So if we see Apache has 2 occurrence, so we'll do 1 plus 1, which will give me output 2 like this. And similarly, Spark has 2 occurrence, so we will be having the output 2, and is has 1 occurrence, then we will be having output 1. So this is how the word count example will look like. Now let's see this in the implementation of Pyspark. So we have seen till flatten, where we have created each word as a separate row. Now we have to assign 1 so that we can then do the sum on the number of occurrences of 1. In terms of a key based operation, think of it as a dictionary. So let's say if I create a simple dictionary in Python, then I can assign each elements into the dictionary. You can see that the dictionary is currently empty. I can add the elements in the dictionary. So Apache, since it has 1 occurrence, then we can see that the value is currently 1. Similarly, if there are more elements in the dictionary, we can keep on editing it. If the element already exists, we can add a 1 to it. If it does not exist, then we can insert into it. There is a concept of a pair RDD. Pair RDD means the RDD of key and value. So whenever we want to assign this particular one to the RDD, what we can do, we can use the tuple. So the input is Apache. Whenever we are going to apply map on this particular Apache, and whenever we want to apply a 1 into it, or we want to add 1 into a RDD, you can use tuple. So X means that whatever we have in the input row, and we are going to add 1 to it. So if you now see this, you can see that we have a tuple of rows, we have the Apache, which is X, and comma 1. So similarly, for all the elements in different rows, you can see that we have added 1 to each of them. Once we have assigned 1 to the RDD, we can use the reduce by function. So over here, first we are going to assign 1 to each element in the RDD, and then we are going to assign reduce by function. So reduce by key, since now it is a key value pair, we have created a key as RDD rows and the value as 1. So each key is the word that we have and the value is the 1. Now I want to add the number of occurrence of each word. We are going to use the reduce by key operation to perform the sum. So reduce by key works similar to the group by key, with the addition of performing the addition operation in between. So if we want to apply a group by key, then we have group by key, which will just group the data together, and then we have to perform another transformation to sum all the data that is available on that key. Instead of that, we can use a reduce by key operation. Advantage of reduce by key operation is that it can use the local aggregation first. So for example, if we have the word available on 3 nodes, and let's say there is this particular node which has Apache available over here. Similarly, we have the Apache available over here, and we have the Apache available in the second node as well. So when we do a reduce by key, it will first do the sum over here. So the sum over here is 2, and the sum of Apache occurrences 1 in the second node. So we have 2 occurrence over here and 1 occurrence over here. It does the local aggregation first, so that we can avoid the data movement into different nodes, which actually cause the latency in the computation. So once we have done the 2 and 1 over here, you can send the result into one node. So instead of now passing the multiple data at once into different node, you can do the local aggregation. So 2 is here, and then we are going to add 1 to it. So we have the 3 occurrence of Apache. Similarly for all the other elements. So using the reduce by key is actually very efficient, and we should avoid using group by key whenever you want to perform some aggregations on the data set. So in this particular case, when we apply a reduce by key take first 2 rows as an input. So if I say lambda a comma b, which means that we have first 2 row over here as an input. So it will take first 2 rows. Let's say if the example of Apache, if there are 3 occurrence, then it will first do a sum on first 2 occurrence, and then it will do a sum on the third occurrence. So if I do a collect like this, you can see that it provides me the word count. So the Apache occurrence is 1. Similarly, Spark occurrence is 3, and all the occurrence of the elements is now available in the output. So this is how you can implement word count using Spark RDD.